Okay, everyone. My name is Tony, and what we're doing here with Patricia and Sophie is an explanation on the difference between ports and channels. So we have a device here that is multiple ports, single channel. And what this demonstration shows is how the current is affected and travels to the actual destination tissue on a single channel system using multiple ports. So we have the face pads connected on two of the ports of this system here. The third port is the probes, and the probes is connected to the third port of the single channel system. We do have it at full power, just so we're using its maximum availability of deliverance of the current. This device claims to be rated at about 500 microamps maximum. But what interesting about current is it only travels when there's a load based on the skin surface area being treated. So we have the current meter connected right now to the probes. Although we do have the pads connected on two of the ports, but the meter is connected to the probes because we want to see what actual current is being delivered to the probes while we have the pads connected to the same channel that the probes are connected to on the first two ports. So Patricia, go ahead and right now we got it. It's because we don't have a load, so it's really not showing much current at all. But go ahead and tap the probes together just to show everyone that we are connected to the probes. So you can see that the meter is actually registering when the probes do touch. So what we're going to do, our concern is we actually want to see the current that is being delivered to the skin. So Patricia, why don't we go ahead, we already have the pads connected to the skin. Let's go ahead and now touch the probes to the skin. Of course, you're going to want to place a little conductive gel on the skin so we can see how the meter is going to react to that. Because right now the current is being delivered through the face pads that are on the skin. So how much available current do we have left that could be used for the probes? This is why when a device monitors skin impedance, it's very important that it can make adjustments based on the amount of surface area being treated. So right now we're using channel 1, channel 2, and now the probes on channel 3. We'll see how much current is actually going to be delivered through the probe. So go ahead, Patty. Just place it on the skin as if you were going to do an eye treatment. So let's watch the meter. Okay. Right now we're showing about 225 microamps, which is about half its maximum rated current that you're going to get delivered with the probes. So go ahead and Patty, lift the probes up. So you can see when we lift the probes up, there's no current because there's no load. Touch the probes again to the skin, and our maximum amount of available current with this particular signal is going to be about 250 microamps, which is about half its rated. You can see the reason why it's about half is because the face pads are taking most of the current and not allowing the probes to compensate to give the proper deliverance to the face, because there is no way that the ability to monitor that skin impedance or resistance. So we're losing about 50% because of the face pads connected to the same channel via port 1 and port 2. So now we're going to show what we mean by skin impedance monitoring and how we can, through a complex algorithm, output perfect levels based on the amount of skin surface we're treating with the other machine, the NEUROTRIS machine that has skin impedance monitoring. So let's hook up that machine. Okay, I'm here with Patricia again and Sophie, and now we switch the machines and using the NEUROTRIS PicoWave. It is a single channel, but it does have multiple ports, and we're kind of hooking it up the same way we did with the other machine to compare apples to apples. We have one of the ports is connected to the face pads, and the other port we're going to use for the probes. So we're setting the protocols as per the manual for this nano program, and we want to see what current we're going to deliver while we're connecting the face pads to the skin. As you can see, of course, we don't have a load on the probes. We do have the load on the face pads, but we're measuring from the probe because our concern is to see, while we're connected the face pads to the skin, how much current is going to deliver to the skin via the probes. So right now the probes are not touching the skin, so there's no current flowing, so we're virtually at zero. So Patty, why don't you connect the probes to the skin and see what kind of value we're going to get. Go ahead and place the gel and connect it to the same area that you did the other probes so we can compare apples to apples. So let's try it out and see what we get. Well, look at that. We are getting about, it's about 750 microamps for this particular client. Now, this machine has a skin impedance regulation system that monitors the density of the skin in relation to the skin surface area with the probes and the pads being treated to output perfect levels based on a complex algorithm that'll deliver the amount of signal to the destination tissue. That's what it's requiring for this particular client. So we're about 700, 800, depends on the hydration level for that day. So I would say about 800 is average. So you can lift the probes up now. So let's try something different. If we were to change the program, you could see that we can try Pico, and we may even get a different level with that based on the Pico program. So we're going to try that. So see what you get on that. So each particular program requires different levels in order to be efficacious for that particular program. So this program on the Pico program requires about 655 microamps. As you can see, this is what we're reading now on the microamp scale. So this is a fluke meter that measures microamps, and we're at about 600-700. So based on the probes and the pads all connected, so you can see the importance and the significance of impedance monitoring, because the more ports that you're using and the more skin surface area you're covering with your output accessories, you're going to need a device that is going to monitor and measure that so that we can get the proper levels. So and that's how it works. So you can see the significance of that. Anyway, thank you for your time and appreciate your interest.